Hey guys, Mr. Midas is here. How you doing today? This is, for me, it's Friday. I don't know when you're watching this, but it's Friday, so we got to be happy and celebrate and kind of relax. But hey, you're watching a calculus video, so you must not be relaxing too much. Anyway, in this one, this is for BC Calc. We're looking at convergent and divergent series, and more specifically, we're going to look at the geometric series and the nth term test. Now, I'm going to split this up into 3 shorter videos. So the first one, we're just going to talk about a series. What is a series? And what does it mean for it to be divergent or convergent? And how is that a little different than a sequence? So, all right, now, just to let you know here, if my bell rings, I'm at work right here at school, and it's about time for the bell ring. So if the bell rings, just ignore it, okay? So recall from the last lesson that a sequence is an ordered list of numbers. And what we're going to do is we're going to change from looking at a sequence to a series. And a series is the sum of those numbers. So we're actually just going to add up a sequence. So an infinite series is a series where we add up, an infinite number of terms. And believe it or not, some infinite series actually sum to a number. And I'll show you an example of what happens. So we have some series, which happens more often than not, is that more and more terms of a series, like 2n plus 1 as n equals 0 to infinity. Now we've seen the sigma before, right? N equals 0. We're going to plug in 0. We're going to get 1. We'll plug in 1. We're going to get 3. We'll plug in 2. We're going to get 5, and so on and so on. And we're going to add them all up together. Well, what happens? 1 plus 3 plus 5 plus 7, these numbers are getting bigger and bigger and bigger and bigger and bigger and bigger and bigger, right? So the limit as n approaches infinity of this sequence is going to go out to infinity. And in fact, as we add those numbers up together, that sum is going to get bigger and bigger and bigger also. And so since the sum of this, remember this is a sum, since the sum approaches infinity, all right, the sum of this approaches infinity, we're going to say that this series diverges. Very similar to what we were doing with sequences. So this is called a divergent series. Well, take a look at this one. 3 over 10 to the n. Well, that's 3 over 10 plus 3 over 100 plus 3 over 1,000 plus ... And what's going on here? Well, 3/10 is 0.3. 3 100ths is 0.03. 3 1,000ths is 0.003, and so on. And so what does that look like? Well, that's going to be 0.3333 repeating, right? It's going to go on forever. It's a repeating decimal. But as you remember from a long time ago, what is 0.3 repeating? That's actually a fraction, right? That's 1/3. What? Did that infinite series just add up to a number? It did. This type of series is called convergent. All right, so this is an example of a convergent. In this case, it's a geometric series, and I'll explain to you in the next video what exactly a geometric series is. But the idea here is that when the sum of that sequence goes to infinity, that series is called divergent. And when that sum actually goes to a number, that's called convergent. All right, so we have a divergent and a convergent series. In the next video, I'll go over what a geometric series looks like. Okay, talk to you later, guys. Bye.